Graham walks 8 blocks from his home to the library. He always walks 4 blocks east and 4 blocks south. So I'm going to draw a little grid, top view here. I'm going to draw 4 blocks this way and 4 blocks this way. East is in this direction. South is in this direction. So if he's walking from his home, east and south to the library, this is our possibility. Now, Graham is a pretty intelligent human being. And when he goes to the library, he does not get lost. He is also intelligent that he would never choose this as his pathway. Whoa. Whoa. Oh, I'm there. That would be a very non-efficient way. We're going to assume that Graham is smart enough that when he's going to the library, he's going to be efficient. And he always has to walk 4 blocks east. Does it make sense that you're going to have to do 4 to the east and 4 to the south somewhere? So he could do all 4 east, all 4 south. That could be a possibility, right? He could do this as a possibility. This route would be a possibility. And each of those routes, like the green one, I could represent the green one like this. He went east, then east, then east, then east, then south, then south, then south, then south. I could write the blue one like this. South, then south, then east, then east, then east, then south, then east. Or the purple one. That looks easy. So all of those are just arrangements of the E's and the S's. Can you see this is a Mississippi question? Because the total ways, if they were all different, would be 8 factorial, but you have 4 E's and 4 S's, so we can count it that way. If you type this into your calculator, again, 8 factorial might be one you don't have memorized, but 4 factorial, I think you should know that that's 24 times 24, makes your life easier. We get 70 in total. But I also want to show you that with these pathway ones, you can count them in a systematic way. So here's Graham, starting at home. If he wants to walk to this spot here, can you see there's only one path to get to that spot? As long as he doesn't backtrack, right? There's only one route to get to that spot. In a similar way, there would only be one route to get to that spot. In fact, even if you wanted to go to any one of these, straight across or straight down, there's only one path to get there. If he wants to get to this far corner, he has to take the straight path there. That's the only path possible. Otherwise, he would be going down and coming back up. But this one, can you see that you could get there either over and down or down and over? There would be 2 ways to get there. And this one, you could go over, down, down, or down, over, down, or down, down, over. There would be 3 ways to get to this one. And 3 ways to get to this one. And there's a pattern that's coming up, and I'm going to show you the next diagonal, and then I want to see if you can see the pattern. There's 4 here, there's 6 here, there's 4 here. This pattern's pretty easy. What number goes here? 5. Not as easy. What number is going to go there? I'll let some other people, everybody think about it. This one's going to be 5 as well, because you maybe use that pattern 1, 2, 3, 4, 5. But the idea is this. If there are 6 ways to get there, and there's 4 ways to get there, I can get to this next spot either through the 6 ways or through the 4 ways, making 10 ways in total. See the 6 that was there before? 3 plus 3 is 6. 6 plus 4, this will be 10. Can you see this one will now be? 15, 20, 15, 35, 35, and sure enough, we get our 70, counting it that way as well, right? So the Mississippi method is nice, but the Mississippi method sometimes runs into problems when, like, oh, what happens if you had a lagoon there and you weren't allowed to walk there? Now you have to use this technique instead, and it'll change the numbers. So we're going to use that strategy as well. Okay, questions for practice on this one are 12. And we have one more identical object